welcome to the deep dive.
Ah.
Okay, so imagine this. It starts raining, and instead of seeing your solar output dip,
Mm.
what if that rain actually boosted your energy production?
Mm.
Sounds counterintuitive, right?
Right.
Rain is usually seen as, well, the enemy of solar power.
Exactly. Clouds, less sun, lower power.
But today we're going to unpack a pretty fascinating idea, rain-powered solar technology, and specifically what it could mean for a place like Missouri.
Yeah, and what's really compelling here, I think, is the synergy. It's not just sticking a rain barrel next to a panel.
Right.
It's designing a system where, water and solar power generation actually help each other out. It's really about tackling both energy and water needs together, kind of blending innovation with sustainability.
Okay, so that dual benefit,
Yeah.
that's the core thing. How does it actually work, like on the panel itself?
Well, basically, it integrates a rainwater collection system directly with the photovoltaic, the PV panels that we're used to seeing. And it does two key things really smartly. First, the rainwater that's collected is used to cool the panels down.
Ah, because they get less efficient when they're hot.
Precisely. Heat drag is a real thing for solar efficiency. So cooling boosts the power output.
Got it.
And second, that very same water, once it's done its cooling job, is collected. Clean water, potentially usable for homes or maybe small-scale farming. Dual purpose.
Dual purpose functionality.
Okay. And thinking about Missouri, how does this fit with its specific climate? It's not exactly Arizona.
No, it's not. And that's what makes it interesting. Missouri is currently 34th in the U.S. for solar capacity. Over 680 megawatts installed.
Powering quite a few homes.
Yeah, about 68,000 homes. And there's investment happening, like American Missouri putting nearly $1 billion into solar.
Okay.
But Missouri also gets, around 206 sunny days, which is decent, but it also gets significant rainfall. Plus, you've got wind, 812 mile per hour on average, and, occasionally tornadoes.
Right, severe weather factor. Exactly. So this tech, which uses rain, suddenly looks potentially really well-suited. It kind of turns a challenge, the rain, into an asset.
Okay, beyond just the tech itself being cool, here's where it gets really interesting for people, I think. The benefits. What are the tangible wins, economically and environmentally?
They're pretty compelling. First, lower electricity bills because the panels are working more efficiently thanks to the cooling. Plus, you're saving on water costs if you're harvesting and using that rainwater. That can add up.
Sure.
Then you layer on the federal tax credits, maybe some local incentives. It really improves the long-term return on investment.
Okay, so the ROI looks better. And environmentally?
Environmentally, it's straightforward. Less reliance on fossil fuels, cleaner energy generation, contributing directly to Missouri's carbon reduction targets. It's a clear win-win for your wallet and for the planet.
That sounds great on paper.
Yeah.
But, people ask about resilience. Missouri gets hammered by storms sometimes. Is there proof this stuff can actually hold up?
That's a fair question. And yes, there are examples. Take the Waterford Solar Farm up in Connecticut.
Okay, Connecticut.
Yeah, they got hit hard by Hurricane Ida, heavy rains, strong winds. But the solar farm, which incorporates some robust design principles, kept operating efficiently right through it.
Yeah.
It powers about 3,700 homes, so it's not a small experiment. Its success really speaks to the potential for resilience, even in challenging weather, which is relevant for Missouri.
But like any new tech, there have to be hurdles. What are the main roadblocks for getting this adopted more widely in Missouri? Cost is usually a big one.
You're right. Cost is definitely a factor. And robustness. Designing systems that can reliably withstand Missouri's potential for tornadoes and really strong winds, that's a key engineering challenge.
And a cost figure.
Well, a typical 5-kilowatt solar setup might be around, say, $13,000 to $14,000. Add a rooftop rainwater system, maybe another $1,000 to $5,000, depending on complexity. So you're looking at maybe $20,000 combined, ballpark.
Okay, that's a chunk of change up front.
It is, but, and this is critical, those incentives we mentioned, federal tax credits, local programs, they can significantly bring that number down.
Right.
So careful planning, really leveraging those incentives, that's crucial to making it work financially and ensuring these systems perform well over the long haul. It does raise that important question, though. How do we make these advanced solutions accessible?
So what does this all mean? Wrapping this up for Missouri. Rain-powered solar seems like a genuinely promising direction.
Yeah.
It offers real economic and environmental pluses with that dual function power and water. And with incentives helping bridge the cost gap, it looks like a viable option, not just a futuristic dream.
Exactly. And maybe the final thought for you to consider is just how this technology flips the script. It shows that things we often see as opposites, intense sunshine and heavy rain, can actually be brought together, ingeniously harnessed to create solutions that are both powerful and sustainable for energy and for water. It really offers a compelling blueprint, I think, for resilience and resourcefulness as we navigate a changing world.